We're going to work on balancing redox reactions in basic solutions. So this will have the added step of adding hydroxides to both sides. So the first thing we're going to do here is determine our oxidation numbers. We can see that we have aluminum at 0, and it's going to a +3 on the other side. This is being oxidized here. We're losing electrons. It's oxidation. Here we have nitrate going to ammonia. We have +5 changing to -3. So this is a really big reduction here. So we're gaining electrons and we're being reduced. In our next step, we're going to balance the mass. Okay, we have aluminum in our oxidation side. We have aluminum turning into aluminum with 2 oxygens and a -1. Remember that to balance oxygens, I'm going to put in a water. So on this side, I'm going to put in 2 waters to give me 2 oxygens. Now, I'm going to balance my hydrogens. I have 4 hydrogens here. I need to put 4 hydrogens on the side. And again, when we have a basic solution, we're going to add a hydroxide to both sides to equal the number of hydrogens. So on this side, I'm going to put 4 hydroxides. And on this side, I'm going to put 4 hydroxides. This will give me 4 waters. So I'm going to rewrite this. I can see that I have waters on both sides, so I'm going to cross out this one and change this to 2. All right, now that we have our balanced mass, we're going to balance the charge. We have 4 negative on this side, and on this side, we only have 1 negative. So that means that we're moving 3 electrons here. So to balance the charge, we're on step number 3. We're going to take our aluminum and turn this into 3 electrons being lost here in this oxidation. Let's look at our reduction side. We have our nitrate ion turning into ammonia. First, we're going to balance our oxygens. We have 3 on our reactants and none on our products. So we need to put 3 waters onto the side. Now we're going to balance our hydrogens. I have 6 plus 3, 9 hydrogens on this side, meaning I need to put 9 protons on the other side. And again, since this is a basic solution, the amount of hydrogens that I have put, I'm also going to add that same amount of hydroxides on both sides. So I'm going to have my nitrate ion plus 9 hydrogens plus 9 hydroxides to give me NH3 plus 3H2O plus 9 hydroxides. Now this gives me 9 waters. And we have water on both sides. We can cancel it out. Actually, we'll just get rid of that number. This becomes a 6. We have NO3 plus 6 H2O goes to NH3 plus 9 hydroxides. If we look at the overall charges now, we have -1 and -9. That means there's a movement of 8 electrons to get to my -9 on this side. So we're going to balance our charges here. And we're going to add in those 8, not hydrogens, 8 electrons to give me 2 sides that have the same charges. Both sides now have -9. In my next step, I'm going to, oops, that's number 4. We're going to think about a common number to get our electrons the same. We have 3 on one side and 8 on the other. So my common number here is 24. To make my oxidation side equal to 24 electrons, I'm going to times everything by 8. Giving me 8 aluminums, 8 hydroxides, oh, not 8. I will have 32 hydroxides, 8 aluminum, plus 16 water, plus 24 electrons that we wanted. For this side, we want it to be equal to 24 electrons, so we're going to times everything by 3. 3 nitrates plus 18 waters plus 24 electrons gives me 3 ammonia plus 27 hydroxides. Now, we're going to add our half reactions. We have 8 aluminum, 32 hydroxide, turning into 8 of our ion here, plus 16 waters, and 24 electrons. We have 3 nitrates, 18 water, 24 electrons, going to 3 NH3 plus 27 hydroxides. We have some things that we can cancel out here when we're making our addition. First, we have 27 hydroxides, and on this side we have 32, leaving us with 5. Here, we have 16 waters and 18 on the other side, leaving us with 2. When we add this together, and of course we cancel out our electrons, we have 8 aluminum plus 5 hydroxide plus 3 nitrates plus 2 waters give us 8 of our ion here plus 3 NH3. If we look at our overall charges of both sides, we can see that we have -8 here and we have -8 here, meaning that we have correctly balanced our redox equation in a basic solution.